Today we are going to discuss another problem in which we need to derive an expression for equivalent stiffness of the system shown in figure. It's basically a beam, okay? So it's a beam which is supported on its two ends. Okay, at the center of the beam there is a mass block, and this is attached to the spring, which is again attached to the ground. So the spring has stiffness K. The material properties of this beam are EI, modulus of elasticity and moment of inertia. The mass is attached at the center of the beam. So if the beam length is L, then the mass from each end of the beam is at a distance of L by 2. So what we want to do is we want to find the equivalent stiffness of this system. So how to proceed? Basically we need to understand that the beam has its own stiffness. So the stiffness of the beam you can find by using the deflection equation of the beam. The beam is simply supported, so the stiffness of the beam we can write as equals to 48 EI over L cube. Okay, so from the stiffness of the beam you can find the stiffness, the deflection of the beam, you can find the stiffness of the beam. Now the equivalent stiffness, that is K equivalent of this configuration, is what we desire. That's what we want to find. In that case we need to understand how the spring is going to behave when it is connected to the beam at the center. Okay, so what's going to happen is when the mass M is put, mass of block M is put on the beam, then the deflection of the spring and as well as that of the beam is going to be the same. Okay, so let's write this down. This is very important. The deflection of the beam is going to be equals to the deflection of the spring. So when the deflection is same, then we can safely say that the system of stiffness is basically in a parallel configuration. Okay, so always remember that if you have two springs, okay, so this is K1, this is K2. Okay, now these two springs have one block of mass M and a force is applied, then the deflection of these two springs is always going to be the same. In that case, these two springs are in parallel configuration. Okay, so these are in parallel configuration. What happens in parallel configuration is that the forces are added and the stiffnesses are added. Okay, so the K equivalent in this case will be equals to K1 plus K2. Okay, so similarly in our case what we can do is we can say that K equivalent will be equals to K beam plus K of the spring. Okay, so in our case K equivalent will then be equals to 48 EI over L cube plus K of the spring is simply written as K as given in the figure, and so this is going to be the final answer. Thank you.